So I'm going to record some videos that go over the weekly reading questions, and so the one since second half. And so I'm going to just start with weekly reading questions number 7. So where does the salt in the oceans come from? This comes from weathering of rocks, and the salt in the rocks gets the weathering creates salt ions, salt compounds that run off, that get incorporated into runoff from rain, and then get taken to the oceans. And the oceans are not getting saltier with time. No, they're not. And if not, then why not? Because it's in the source of salt to the ocean from weathering is equal to the use of salt by critters in the ocean. And so this creates what's called an equilibrium. Okay, define the thermohaline circulation. So as I've mentioned a number of times, this means temperature, this means salt, and what processes drive the circulation of the deep oceans? It's really density. Density is caused or is determined by both the temperature of the water and the salinity. And so when you have cold water and saline water, that's going to be dense, and that water is going to want to sink. And that's what happens in the North Atlantic deep water and the Antarctic bottom water. Antarctic bottom water areas. Explain the differences between the pycnocline and the halocline and the thermocline. So the pycnocline tells us about density. This is the density profile with depth. This is the salinity profile with depth. And this is the temperature. The temperature with depth. That's what these represent. And so that's how they're different. They represent different different quantities. And so you can look at that graph in the textbook that shows those profiles and how they differ with depth. But the surface is different than, in each of these cases, the surface is different than the deep ocean. And this is what distinguishes the surface layer from the deep ocean. What is bottom water? This is water with very high salinity and low temperature. So it's going to have a high S, meaning salinity, and a low temperature. So it's going to be cold and saline. And where and how does the bottom water form? And as I mentioned, this is shown up here, the North Atlantic deep water. So the North Atlantic, and also around Antarctica, the Antarctic bottom water. And what is the term, the thermohaline conveyor belt? This is a term that's given to the thermohaline circulation for how the water that sinks in the North Atlantic takes with it warmth and or actually that's it, that it takes with it when it sinks down in the ocean, it takes with it, for instance, CO2. That water is relatively warm compared to the deep water, but it also takes with it CO2, and it also keeps this thermal conveyor belt goes all around. It sinks in the North Atlantic, and you can see the figures in the book that are called out in the study guide, where the water goes south to the Antarctic, and then circles around the Antarctic current, and then comes back up then travels north in the Pacific and then upwells in the Pacific. So that conveyor belt is what helps to take surface waters, which are rich in CO2, down to the deep ocean. And then finally, explain what effects the ocean has on modifying the global temperature distribution. And again, you should look at these figures in the book. And really what it does is it transports heat from the equator to the poles. So it moves heat from equator to the pole, towards the poles. And this helps to alleviate the surplus of solar radiation that we have at the tropics relative to the poles that we saw in chapter 4. So those are the answers. Also, I'm going to just put a little copyright on this. Just a second. This is copyrighted by Vaughn Walden at WSU, so don't post it on the internet. Okay?